Hey everyone, welcome back to another edition of Can You Hack It? I am your host Ben, and this week we're going to be doing something a little bit different than I normally do. We're going to be taking a look at a specific vulnerability that was discovered recently rather than a specific box on one of these hacking challenge sites. The vulnerability we're going to be looking at was one discovered in Snapd by a researcher named Chris Moberly. And the vulnerability itself, which we'll take a look at the code, the vulnerability itself is in the API for Snapd, which, if you're not familiar, snaps are a new package manager or newer package manager that's used on Ubuntu and other systems, but primarily Ubuntu systems. And what they do is they kind of package the application along with all of its dependencies, similar to a container, and install it. And basically the vulnerability he discovered was in the way that authentication is handled when you're accessing the API through these Unix domain sockets. And so what I'll do first is we'll take a look at the actual vulnerable code from Snapd. This has since been patched, and so if you haven't already done it, make sure that you update Snapd. I think actually Snapd will update when you install a snap, so even if you didn't intentionally update it, you may have accidentally updated it. In which case, if you try and reproduce some of the stuff you see here, you may have some problems. So like in the VM that I'm going to use to demonstrate a lot of this stuff, I have my internet connection disabled so that it doesn't update. There were some people out there that seemed to have a problem when their internet connection was disabled. They weren't able to get the API calls to work. It should work if you just do something like, if you're doing it on a physical box, unplug the network cable or disconnect from the wireless. Or if you're doing it in a VM, just disconnect the network interface. Don't disable it. And so what we'll look at first here is just the accept function. If you're not familiar with Go, I'll just kind of walk through it real quick. I've written some code in Python that's going to demonstrate how this works without having to have all the extra cruft associated with Snapd. And I decided to use Python rather than Go just because I feel like more people are familiar with Python and it's a little bit easier to understand. But we'll run through the original code real quick just so you can kind of see what's happening. So when it accepts a new connection, one of the things it does right here, where it's called getUcred, is I assume inside of getUcred, which actually I could have found the function itself, but I'm going to hypothesize here. So they've got a file descriptor for a function. They're setting a socket option, and this one here, SOPureCred, should get the credentials for the remote side. So it'll get the UID, PID, GID for the other end of that Unix domain socket. And so what they're doing is they're doing that call to get the credentials. And then, let's look further up here. So they're getting a string from it. And then in that string, they're actually parsing it. So this ucred net get, they're passing in this remote ADDR string, and then they're returning a PID, a UID, a socket, and potentially an error. And basically what they're doing inside of here then, well, sorry, I shouldn't have skipped ahead. When they're building their string, what their string is PID equals, and then they're populating the PID that they got from the socket, the ancillary data that comes off of that Unix domain socket. And then the UID, they're setting, UID equals, same thing with the socket equals, and then finally the remote address. And so then what they do is they just loop through, they do a split on that remote address, so they split on their semicolons, and then they're just looping through, and if the token has PID equals in it, then they're setting the PID. If the token has UID equals in it, then they're setting the UID. And otherwise, if it has socket, they're setting the socket equal to the token. And then they're using this later on in order to determine what credentials to run under. And so now we'll finish up with this code, and I'll start showing you the code in Python, which we can actually run, and you'll be able to actually see what's happening. So in this code called flaw demonstration, this is all available on GitHub, by the way, so I'll post the link to it. But this is just fairly simple. Let me see where the best place to start is. So the way this demonstrates it is first it runs it without exploiting it. So it runs it in the manner that Snapd would expect you to connect, which basically it's starting up a server socket, this server socket up here. It's just unlinking the server socket, which is at, in this case, temp example.sock. I think on sockd it's in like var run sockd.sock or something like that. You can see it in Chris's code. And so basically, for run server, we're creating a new Unix domain socket, and then we're binding it to that file, and then we're listening for a connection. When we get a connection, we accept it. We call this get socket options, SOL socket, SO peer cred, and then we're calculating the size of the structure that we need to hold that stuff, which is 3 integers. And then here we unpack it. So we unpack our PID, UID, and GID. We're printing it out just so you can see them. We're building the authentication string that they have. So we're basically just doing a PID equals, and we're joining that with a semicolon to UID equals, and then we're joining that with a semicolon to socket equals. And then we're calling a function called parse authentication that parses it in a manner similar to what they do, where they're just taking that auth string and they're splitting on the semicolon, breaking that into tokens. And then based on what the token starts with, they're setting either PID, UID, or socket. And then finally, we just print out what those values were. It's a little messy. Maybe before I post this video up, I'll clean things up so that it looks a little prettier when it all runs. And so the first run through, we're just, for our client socket, we're allowing it to just randomly assign it, which in the case of Python, I think it ends up in some anonymous namespace, and so it's just some byte value. It's nothing interesting. And then we run the version that actually uses the exploit. And so basically we do the same thing. We start up our server thread the exact same way. But this time when we run our client, we run it on a named socket. So actually I didn't show that before. So running on a random socket, all we're doing is we're creating a Unix domain socket, we're setting our socket option to pass the credentials, and then we're connecting, we're sending a message that's echo, we receive it back, and that's that. And so there's nothing real special about that. But then on this run client on named socket, what we're doing is we're using the client name that we gave up here, so this client ADDR, and this name is in /temp/dirty.sock, and then you'll notice we have this semicolon UID equals 0 tacked onto the end of it. And so what's going to happen there is we're going to do the same thing where we're creating a socket. This time we're creating a socket. We're setting the option to pass our credentials. This time we're binding, and we're binding to that specific address you saw above, the /temp/dirty.sock semicolon UID equals 0. So this time we're binding to a specific address to use as our source. And then we're connecting to the server the same as before, and the rest of this is the same as before. I could have technically abstracted this out into its own function so that they both use the same one, but I felt like this was a little bit easier to see. So we're basically just sending echo again, and we receive it back, and we close, and that's that. And so what happens though in this version, where this is the name of our socket, is when we receive here, this socket is set to our remote address again, which this is our remote address. And so socket is set to /temp/dirty.sock semicolon UID equals 0. And so that string actually ends up having PID equals what the PID is, UID equals what the real UID is, socket equals to our socket, but then it has an additional semicolon UID equals 0 that we tacked onto the end. And so then when it goes into this parse function this time, it's going to parse through, it's going to find its first PID, it's going to find its first UID, it's going to find its first socket, but now it's going to actually have parsed on that piece that we added to the end here, this semicolon, and it's going to have one more entry in there, and that's going to be UID equals 0. And so that'll actually end up overriding the value of UID, and it'll set UID to 0, and this is what happens in the real exploit. And so because of that, our user ID as far as that remote server is concerned is now root. And so like I could run it in here and show you, since I'm running as root, nothing's going to actually change. But basically we run, it's able to get the process ID, our user ID, our remote socket name, which is just probably a file descriptor maybe based on this value. And so it's just a single byte in this case. I guess we could confirm that by if we run again, it should increment. And then this time it's running, exploiting the code flaw, and UID is 0 again. In this case, like I said, you can't see it here because of the fact that we're already root. But let's open up a terminal. It's clear. Let's SU to one of my random users like U1002. And then, or actually here, let me see real quick. Let's exit back into root. Let's change to my PyCharm directory. Okay, so now we'll SU to U1002. So we're user 1002. If we run it now, so Python 3 flaw demonstration.py. Oh, I might not have cleaned up that socket. Let's exit out of this user ID real quick. It's rm temp example sock and rm temp dirty sock. So of course, if those files already existed, it's like anything else. If they were created by root, we wouldn't be able to touch them. And so now we can see in the first run where we're running the code as intended without exploiting the flaw, we've got our PID here. We've got our user ID, which is 1002, which is matching the user I switched to. We've got our socket, which it looks like is incremented by 1, so it probably is a file descriptor. The server got echo, the client received echo back, it closed, and that was that. Then we exploited the flaw here. And so again, we bound, the client sent echo, the server received its new connection, which technically the server received its new connection before that echo was sent, but the order of things here is off. So this time the connection was from /temp/dirty.sock semicolon UID equals 0. And so you'll notice now what was originally found from that ancillary data from our Unix domain socket was our PID, our real UID, and our real GID. But the parsed authentication, you can see that we overwrote that UID. Now the UID is set to 0. Our sockets, the socket name without that semicolon UID equals 0 in it. It echoed, it received it back, and everything was happy. So the thing we ended up doing there was overriding who the server thinks we are. It thinks we're UID 0 now. And so that's what happens in the real code. And so now if we take a look at this other tool I wrote called SockPuppet, this is pretty heavily based on Chris's actual exploit code. So he has 2 different versions of some POC exploit code. One of them leverages a slightly different part of the API than this one does. This one leverages the same pieces of the API as his second version of the code. And in fact, in parts here, like the installing the snap and the removing the snap code, it's mostly Chris's code. I think there's a few tweaks here and there, but for the most part, it's Chris's code. Chris's code was set up to run a specific exploit where it basically just uses this command here. It creates a user called dirty sock. It adds him to sudoers, and it adds him to the sudo group, and then it adds him in the sudoers file. And because in his, this is actually not just text like this, it's actually all pre-packaged into a snap. So he's got a snap built that's base64 encoded inside of the file that has this in it. And so basically you just install that snap. It creates this new user. It actually uninstalls the snap right away too, because the snap itself is empty. This stuff is happening in a install hook that runs when the snap is installed. So when it's installed, it runs this shell script, which has these commands in it. And then after it finishes, he just immediately removes it. so that the snap's no longer there, but the user of course stays because it ran in the install hook. It wasn't actually part of the snap, so it doesn't get pulled out. What my code does here is a little different. So my code creates the snap itself, which allows you to customize the payload. I didn't use Snapcraft, which is the typical way you create a snap. What I did instead is this just kind of creates the directory structure that a snap expects, and then creates some of the metadata files that are required, basically just the install hook and the snap.yaml file. And then it packages that all up by creating a squashfs and gives it a name, and then installs it, and then uninstalls it. So the install and the uninstall part is pretty much what he had. The rest of this just allows you to wrap up something custom if you want to do something other than add a user, which I'll demonstrate by passing in a shell script that'll create a remote connection back to us. So it'll basically allow us to get a root shell on a remote system. So what you can see here is initially when you create this SockPuppet class, you pass in a base directory that you want to do all your work out of, a payload, and then a name, summary, and description. The name, summary, and description don't matter. They have default values. There might be some reason you would want to customize them, which is why I exposed them there, I suppose, if you wanted to not uninstall the snaps but leave them in there for some reason. Then you'd probably want to change the name, because I don't think you're allowed to have the same name. So anyway, what it does here, and when it inits, is it sets all those variables. It creates it sets the proper permissions on this base directory. The snap installer is kind of picky about that. So if the directory structure doesn't have the right permissions on the right directories, then it'll fail out. And so it's setting the base directory's permissions and then setting the rest of this stuff just as stuff that's stored inside of the class. And so then what we're doing, let me see if there's a good way to show this. Okay, so under execute. So the first thing we're doing is building the directory structure. So we go to that. We can see that that basically just means that we're creating some directories here. We're creating, inside of that root, we're creating a directory called meta, and inside of meta, we're creating a directory called hooks. We're also creating a directory called snap, and then inside of that, we're creating a directory called hooks also. Part of this is a little bit of a holdover from Chris's code. I don't think we need or use this snap hooks directory. When you're using Snapcraft, the install hook needs to be both in meta hooks and in snap hooks. When you do it like this, it doesn't seem to care if it's not in snap hooks. It seems to do the exact same thing if it's only in meta hooks, which is the place it's documented as where it's required. So I'm not sure why Snapcraft wants it in the other place, but there's probably some sort of reason. And so basically what we do is we cycle through those directories, we create them, and then we set their permissions. And so that's all nice and simple. Next thing we do is we build the install file. And so there, what we're doing is we're taking our payload and we're sticking it in to the install contents. Again, it's super simple. So it's just whatever your bash shell script is. Then we're building the YAML file. Again, the YAML file is pretty simple also. We've got a template here, but it's basically just the name of the snap, a version, summary, a description, the architectures. I think technically we could leave this out. I don't think it matters. The grade also I don't think matters. Confinement does matter, so we specify dev mode, which removes some of the restrictions that we would otherwise have. Opens up the security a little bit. And so basically we take that template, we put in our values, and we set YAML contents to that. Sorry, my mouse is kind of acting up here, so I'm having a hard time moving it around. And so then we just write the write the install and the YAML files. And so if we look at those, it's nothing more than just writing the contents that we just created to the correct place, which in the case of the install hook is in meta hooks install. And again, we're setting the permissions. And then when we write the snap same thing. So we're writing the snap to meta snap.yaml, setting our permissions there. You'll notice the permissions are slightly different. And then the next thing that we're going to do, I believe, is build the snap itself. Yeah. So if we look at that, building the snap, we're just taking another directory where we want to build our snap at. Again, it's just a randomly chosen directory. And then what we're doing is we're calling make squashfs, and we're passing our base directory, which is where we built out that file structure at, and our install hook, and our snap.yaml, and then we are telling it to write that to this new directory that we just created. And then once that's done, we return and we connect to the API. And so if we look at the connect to the API code, we're basically creating a new Unix socket, which we can see up here is similar to what you saw in the Python code before. So we're just adding a suffix of ;UID equals 0 to some random file name. We're calling that our dirty sock. We're returning it. We're binding it. And so again, same as we saw in the other Python code, we're creating a domain socket. We're binding to our dirty sock. And then finally, we're connecting, and we're connecting to the socket that the server is running on, which is /run/snapd.socket. And so once that's done, we connect, we actually install the snap. And so this goes back to Chris's code mostly. Some parts like up here are modified because he was using a base64 encoded blob, and we are instead reading the snap that we created. So we read in the snap that we created in binary mode. We get a blob of bytes. We configure the multi-part boundaries, which is for multi-part form uploads. I'm not going to cover that here just because if you don't know about it, feel free to look it up. But basically, it allows us to upload form data that contains multiple pieces, and these boundaries are just to kind of let it know where things start and end. For example, at the end of our binary data, we have our boundary, and then these two exit slashes, which tells it that that's the end of the data. But aside from that, we've just got our basic format here. You'll notice we're sticking our blob in encoded in Latin 1. And so we first make a request, which, as he points out here, we make our request, we wait for a HTTP 100 reply, which is telling us to continue. So we send that. If we didn't get 100, then we error out. Otherwise, we build our second request, which has our post payload, which is this that we saw. And we send that. We receive our reply. As long as we didn't get a status code 202, then we're good. We sleep for 5 seconds. That's just to allow the snap to install. Technically, 5 seconds isn't enough in certain cases, like in the case of that I'll show you the second case where we use a script to get a reverse shell, because as long as our reverse shell is open, the install script's not going to finish. And then remove snap here is what would happen afterwards. So you'll see it's remove snap, install snap, and then finally we remove the snap. But the way it's happening down here is we'll go through, we execute, which gets us to the point of installing. Then we have input where we ask you to press a key to clean up the snap. The reason for that is just because if you're using long-running things like the reverse shell that I was mentioning, then you don't want to try and remove the snap until that reverse shell has been terminated so that the install has finished and the removal will work. Otherwise, the removal will error out, which isn't the end of the world in cases where you're just testing like this, but just so that you're aware of it. And so then let's try and demonstrate this code, and we'll do that on a VM that I've set up that's running the latest version of Ubuntu Server. And let me see, let's clear this window out. I think it's SSH. See if I can remember what the username is. I didn't actually prepare for this because I had set this all up last week when I shot the previous video. And haven't revisited it since then. Okay, so yeah, we've got just some random username, Bob. Doesn't have sudo permissions. isn't able to do anything, so he's got no privileges. And I think I already cloned the repository on here also. Let me see. I put it in var. Or sorry, not var, opt. Yeah. Okay, and so we've got SockPuppet. We've got this file called revshell.sh, which we cat that real quick. This will be the file that we use for getting a reverse shell. So it's just the simple reverse shell you've probably seen a million times. Really quickly, too, I didn't point this out in SockPuppet. Let me pull it up. Go up to the parsing of arguments. So there's some arguments you can pass. You can specify a UID to use. This actually, I'm going to make a note to fix this. This doesn't actually work right now. Right now we just always specify UID equals 0, and the reason you can see that is, or where you can see that, is where we're creating this suffix. This suffix should technically be pulling the UID from, well, I suppose I could fix that right now. Self.uid, and it needs to be, oh wait, sorry, this is string. Too many languages. So that should technically work. This won't actually take effect on the system that we're working on, but this is what hopefully I'll have checked back in. So that allows you to specify a UID. You can specify a file or command. Command is just a specific command to run. If you don't specify anything, it's going to use this default command. If you specify a file, it's going to read in the file, so it needs to be a bash shell or a bash script. And then -s skips the cleanup, which basically after this all runs, it removes all the temporary directories that it created and the snap and all that stuff. But you can choose to leave it there if you want to dig through it. So hopefully this still works. Let's take a quick look at let's see password and make sure I don't have an old SockPuppet user in here. Or dirty sock, I do. So let's remove that real quick. Let me switch over to, oh, this is running on also. Okay, so user dirty sock. So we've got some cleanup to do. I'll pause that so you don't have to see it all. Okay, so that's all cleaned up. So now if we cat it, we don't see dirty sock in there anymore. So let's try and run this with the default payload. So we do Python 3 sockpuppet.py. We can see the directory structures that it created, the files, binds to the socket, connects to the API. It's deleting any existing Trojan snap. It's installing a new new snap. And then it asks us to press a key to clean up. We can just press the key now. It's going to remove the old snap. And now we should have a user called Dirty Sock in here, if I didn't screw something up. And so we do. Dirty Sock, he's user 103. So if we su dirty sock, and the default password that's that Chris gave, I think, is also dirty sock. So dirty sock. So now we're dirty sock. If we do sudo -l, and we can see that we can run anything we want. So if we do sudo su, now we're root. So that's how that works with the default payload. Pretty simple. And now real quick, we'll show how like a reverse shell would work. So I actually have the command in here somewhere. No. So if we do nc-lvnp 4444, so now we're listening on port 4444, which I think is the port we're using in this reverse shell. So we cat reverse shell. It is. So now if we do Python 3 sockpuppet.py-f rev shell. So same thing, we're binding to the socket, or binding the socket to our file, we're connecting to the API, we're deleting any existing Trojan, we're installing our new one. You can see the activity light lit up here on our tmux, so that suggests that we probably got our connection. If we switch over to that, we can see we did get our connection. We're now root on Snapper, which is that system. So it's another way to do it. I'm sure you can come up with even more creative ones while I still have that session active. So notice I didn't exit out of it. If I was to press a key to exit here, we get an error removing the snap. And we can see that the reason is that there's a change in progress. Install snap, change in progress. So that's why. Like I said, it doesn't harm anything, but it means that it won't be removed right now. And so what I'll do is I will get this code posted up. If you want to check it out yourself, hopefully this kind of helps clarify this vulnerability. It was a pretty simple one in the first place, but I felt like it was both interesting and lended itself to demonstration. So I figured I'd do something, that way I got a video out there. Hopefully I get some time to start doing Hack the Box videos again soon. I've actually been working on my own box that I'm going to be submitting. It's technically done, but I need to, and I've ran through the different phases of it separately, but I need to get the box built from scratch, do a full run from start to finish, make sure that everything's working properly, and then I need to do a quick look and make sure that I don't have anything in there that would allow you to get privilege escalation a different way than I intended. Like, I think actually I'm using a new enough version of Ubuntu that this vulnerability would work on it, especially if I didn't update snapd ahead of time, which I will do because this isn't the intended way, so I'm not showing you any secrets on how to do my box here. Unless I screw up and don't remember to update snapd and release the box like that, but I'm hoping that at this point I've made a big enough deal about it that I'll remember, and I won't. Hopefully it'll be a fun box. At some point maybe I'll try and do a box that leverages this, but maybe not. I don't know. Anyway, hope you enjoyed the video, and I'll be writing a write-up on this also on my blog. Mostly it'll also link into what Chris already wrote up, because he's already done a great job writing up all of this. He's the one that gets all the credit because he discovered everything. I didn't do anything here other than show you how to use it and extend it just a wee bit. So I will see you in the next video, and hope you guys have a good weekend or whatever day it is.